A gigantic part of Algebra 3 class is trigonometry. Well, guess what? We made it. We're going to start studying triangles, and we're going to start right now with the Pythagorean Theorem. So the Pythagorean Theorem is this, I think, is this really interesting fact about right triangles. So if you have a right triangle, meaning one of your angles is a 90-degree angle, there's this really interesting relationship between the sides. Now, first off, a couple definitions. The two sides that form the 90-degree angle, they're both called legs. Okay, so we could call this like leg 1. We could call this leg 2. But then the side that's always the longest of a right triangle, the side that's opposite from, far away from the right angle, it is called the hypotenuse. All right. And so here's the relationship. This guy named Pythagorean and his followers kind of founded this relationship. Let's say one of my legs is a 3 and the other leg is a 4. Well, Pythagoras and his followers found this relationship that if in a right triangle, if this leg was 3 inches and this leg was 4 inches, that the hypotenuse would always be 5 inches. Now, what is the relationship between 3 and 4 and 5? Well, here it is. It's kind of bizarre. Imagine if this leg is 3 inches. What you could do, imagine if you kind of built a square out of the side of that leg. And this isn't going to be a perfect drawing, but you'll get the idea. Well, this square would be a 3 by 3 square, meaning it would be composed of, it would have an area of 9. Okay? Likewise, I'm not going to draw it all out here, but if we were to make a square out of this leg, it would have a total area of 16. And then if we were to make a square, this is going to be really large, but if we were to make a square out of this hypotenuse, okay, since this length is 5, you can imagine this would be a 5 by 5 square. It would have an area of 25. Well, what happens is that the square of this leg, which is 9, plus the square of this leg, which is 16, in a right triangle, it always adds up to the square of the hypotenuse, which is 25. In other words, 9 plus 16 is equal to 25. And not only is that true of this particular right triangle, that's true of every right triangle. Now, the way we word this, one of our legs, oftentimes the way we word this, one of our legs we'll call A, and the other leg we'll call B. It doesn't matter which one you call which. The hypotenuse we'll call C. And then here's the Pythagorean theorem. A squared plus B squared equals C squared. For any and all right triangles, that is always true. So I'm going to be super nice to you today. I'm going to do the examples directly right off of your homework assignment. So here, determine if each triangle is missing a hypotenuse or missing a leg, and then find the missing side. Well, here my two legs are known. One leg is an 8, the other leg is a 6. I'm going to call those A and B. What we're missing here is the hypotenuse. Okay, so in problem 1, we're missing the hypotenuse. Then we can find the missing side using the Pythagorean theorem. So here's the Pythagorean theorem. A squared plus B squared equals C squared. All right, we know that if we square the 8, which is 64, and then we square the 6, which is 36, and add these together, which these add up to 100, this is equal to the square of the hypotenuse. Okay, well, basically now to be able to solve for the hypotenuse, we could just take the square root of both sides. Now the square root of 100 comes out perfectly. It comes out to 10. And as we just learned in our last lesson, when you take the square root of C squared, that just comes out to C. If this is an 8 and this is a 6, if my legs are 8 and 6, then my hypotenuse must be 10. And there's no units here. We don't know if this is inches or meters or whatever. Just generically, if this is an 8 and this is a 6, this is going to be a 10. Okay. Now, in number 2, you'll notice we're missing a leg. So here I'm still going to label. I'll actually call this A and this B. These are interchangeable, A and B. It doesn't matter. I'll call the 15 a C. So now using the Pythagorean theorem, A squared plus B squared equals C squared. Here I'm going to have to use a little bit of my algebra skills to find the missing side. I know that 12 squared is 144, and I know that 15 squared is 225. Here, if I want to find this missing leg, I'm going to have to subtract 144 from both sides. I'm left with 81. Take the square root of both sides. X is equal to 9. Okay, so the missing leg in this case is 9. So what you're going to notice is, I kind of shortcut it like this. If you're missing hypotenuse, you're going to take the a squared plus the b squared, and then take the square root of that sum. Now, if you're missing a leg, you're actually going to have to subtract. If you're missing a leg, you're going to take the hypotenuse squared. Ultimately, you're going to take the hypotenuse squared minus the known leg squared, and take the square root of that answer to find your missing leg. So that's all fine and good, but what does this have to do with radicals? Why did we study radicals right before we learned this? Well, let's do 4. So here, number 4, my hypotenuse is the 15. One of my legs is an x. One of my legs is a 6, so I'm missing a leg here. But if I write out a squared plus b squared equals c squared, I could get x squared plus 6 squared equals 15 squared. That's a 36, and that's a 225. So here's a case where I'm going to solve this just like I did problem number 2. I'm missing the leg, so I actually have to subtract. I end up taking 15 squared minus 6 squared because I'm missing the leg. Now here, in this example, I'm not going to get a perfect square. I get this answer of the square root of 189. Well, this really takes us back to what we were learning in the last chapter. See, the problem is the square root of 189, it does not come out perfectly. It comes out to this irrational number, as you can see below. Now, some teachers would tell you simply, we'll just round it. We'll write 13.75, close enough. Okay? This is called the practical way to write your answer with it when it's irrational. However, the problem is this practical answer is not 100% accurate. Okay, there's a round off error. Okay, it's not exactly 13.75. It's close to 13.75, but it's not perfectly 13.75. Now the advantage of this technique is it'd be easy to find a number like this on a ruler or a yardstick, a meter stick, whatever. But the problem is it's just not 100% accurate. So this is not how we are going to write our answers. I'm going to insist in this unit that you write your answers what I call the academic way, and that's as a simplified radical. Now I'm going to find the largest perfect square that 189 is divisible by, and I thought it might be 36. It's not. Let me try 16. Nope. You know what? I bet it's a 9. Okay. The largest perfect square that 189 is divisible by is 9. So that means we're going to write this as 9 times 21. 189, when it's factored down, can be written as 9 times 21. And since radical 9 is perfect, since it's a perfect square, it simplifies to a 3. Since 21 is not a perfect square, and it can't be simplified any further, we're going to leave it inside the radical sign, 3 radical 21. Now this academic way, the disadvantage of this technique, it's really hard to place this on a ruler, right? Or a meter stick. Like, it'd be hard to find this number on a meter stick. But the advantage is this is a perfect answer. There's no rounding involved. It's completely, absolutely perfect. This missing side is 3 radical 21. All right, the last problem from your assignment I want to go over with you is question number 9. 9, 10, 11, 12 are a little tricky because your legs and your hypotenuse can sometimes have a radical in like the given information. So let's do number 9. So number 9, I'm going to call my legs A and B. I'm missing a leg here. So once again, in number 9, I'm missing a leg. And then the hypotenuse, I'll call it C. All right, so if I have a squared plus b squared equals c squared. Using the Pythagorean theorem, I would say that x squared plus radical 10 squared, and you know what? I'm going to put that radical sign in parentheses. That's kind of a common thing to do, is equal to the hypotenuse squared, 2 radical 3 squared. So in order to be able to solve this, we need to, I want to show you how we can extend these out. So x squared, this one I think is pretty easy. We learned in the last lesson the radical of a square, a radical and a square really cancel each other out. Radical 10 squared is just a normal 10. But this one's a little tricky because here we have to do 2 radical 3 times itself. Well, what happens is my twos, my normal twos, I'm going to treat as just normal. 2 times 2 is 4. But then my radicals, when you take a radical 3 times a radical 3, that just comes out to a normal 3. And so 2 radical 3 times 2 radical 3 actually comes out to 12. So when I put all this together, I have x squared plus 10 is equal to 12. Subtract 10 from both sides. X squared is equal to 2. Take the square root of both sides. X is equal to radical 2. Now radical 2 cannot be simplified at all. This is just how I'm going to leave my final answer. In this case, this missing side would be radical 2. All right, so I hope that helps you out. Best of luck on this assignment. Let me know if you need any help. Bye.